Hello guys, how are you doing? I trust you're doing good wherever you are. Today, we are going to learn how to identify, or I'm going to teach you the power rails in a laptop motherboard. When you hear the power rails, and power lines, is one and the same thing, right? So, right now, I'm going to teach you how the power is entered into the motherboard step by step, starting from the power adapter until we reach the head of the power rails, right? Especially the CPU, the GPU, those are the end point where the power rails lands at. So the first thing, I'm going to draw the well label diagram for the power supply, starting from the power port. Obvious, we will be having the power adapter here. So this is the power adapter. This is the power adapter. Some people call it power adapter, judging adapter, right? So this is the power port, and you find it is indicated DC in your laptop. It is written in your laptop motherboard. It is written DC in. After the power port, we'll have a component called the PL, or the power inductor. You will find it is written PL1. For some laptops, they use PF for power fuse. So if you find PF or PL, that's one and the same thing. After the power inductor, we'll have the first MOSFET. We call it MOSFET 1. Then after MOSFET 1, we'll be having MOSFET 2. Another name for this MOSFET 2, we call it supply MOSFET. And the MOSFET 1, we call it block MOSFET. In my next video, I'll explain to you why this one is called block MOSFET. The other one is called the supply MOSFET, right? So these two MOSFETs have another pin which connects to an IC called the charging IC. This charging IC, most of the time they use a BQ. They use a BQ. So this is an IC. An IC is an integrated circuit. There are several pins, all sides. There's so many pins, and each of these pins, there's the voltage, or some other pins have the signals. So this IC is normally the BQ. This is the BQ IC, or sometimes they call it charging IC, because this is the IC responsible for charging the battery. So this one, we say this is MOSFET 1 or BQ1. If you find the component written BQ, there's a power MOSFET. So in short, the Q represents MOSFET. In my last video, I explained to you what the L mean. That's an inductor. F for fuse. Q for MOSFET. So this is MOSFET 1. This one is MOSFET 2. These are MOSFET 2. So after MOSFET 2, which we say this MOSFET is called the supply MOSFET, because it supplies power into the motherboard. We have PR1. Let me call PR1 because this is the first resistor in the motherboard, or current sense resistor. Then after here, we expect the voltage to go into the motherboard, right? However, or in addition, we have another circuit joining this main power from the adapter. This circuit is coming from the battery. So here we will have a resistor, current sense resistor from the battery. We have another MOSFET, supply MOSFET from the battery, right? Then so this voltage is coming from the battery. Let me call it a positive bath for battery. So they joined here. So once they joined here, they proceed into the motherboard, and then the first branch of the power supply here, we will be having a circuit which generates 3.3 voltage, and we say this 3.3 voltage supplies the SIO. It also supplies the the processor. And then you have another voltage out of this circuit, which is 5.0 voltage. This is 5.0 voltage, and this one supplies the south bridge of the PCH. Once we have the first branch of the power supply, we'll have another branch here. This branch supplies this is a circuit which supply the CPU. So I know you're confused, guys. Why do I say this one supplies the CPU at the same time this one supplies the CPU? It's good to be confused, because actually inside the CPU we expect so many voltages, because there are so many activities happening inside the CPU. So we do not have only one voltage supply. We have several power supply in the CPU because there are so many things happening here. So the CPU depends on many voltages. So we have 3.3. At this line we will be having 1.05 voltage. We also have 1.5 voltage. Then apart from this one, we have another branch of the power supply, and this one is supplying the PCH. This PCH, we normally call it the platform control hub. So this is the combination of what's called the north bridge. This is a combination of what's called the north bridge and the south bridge. In my next video, I'll explain to you what are the purpose of this north bridge and the south bridge, and all of them are contained under the PCH. Apart from the PCH power supply, we also have the power supply which supplies the GPU. It supplies the GPU. The GPU stands for graphics processing unit. So this is a chipset which is responsible for graphics. It is responsible for enhancing the graphics or clarity of images in a laptop. Then apart from this power supply supplying the GPU, we have another circuit which supplies the RAM. So this one here at the GPU, or let's start from the PCH. At the PCH, we expect to have 1.05 voltage. And again, guys, inside the CPU still we need to have 0.8 voltage. This voltage goes into the FICO. This one goes into the FICO of the CPU. So here at the PCH, we expect to have 1.05 voltage. Same with the GPU also, we need to have 1.05 voltage and also 1.5 voltage for the VRAMs. Then here at the RAM, depending on which type of DDR you are talking about. So for example, if you have DDR1, we'll be having 2.5 voltage. This one is for DDR1. If we have DDR2, we'll be having 1.8 voltage. If we have DDR3, we expect to have 1.5 voltage. If we have DDR3L, we'll be having 1.35 voltage. And if we have DDR4, we expect to have 1.2 voltage. And if we have DDR5, this is for the latest machines, we'll be having 1.1 voltage. And still we'll be having another voltage called the VTT. These are the voltage for the terminals. For the VTT, we'll be having the half of these voltages. If you are talking about DDR1, you'll be having a half of this voltage, that is 1.25 voltage. Same case applied to this one. For DDR2, we will be having 0.9 voltage, and the same applied to other DDRs, right? Yes. So we can go back here. So this is the power supply. From here you have 19 voltage entering into the motherboard. This 19 goes past this power inductor and enters this MOSFET 1. So this is 19 voltage entering MOSFET 1. Once it arrives here, The charging IC, or this one is called the charging IC, controls this supply of power from here to here, and this supply is called phase 1 of power supply. This is called phase 1 of power supply. So this 19 voltage enters here. This gets the signal from the gate of MOSFET 1, and it gives instruction to this MOSFET to forward that 19 past here, past the source of this MOSFET. So this is the source, this is the drain, this is the gate. Once the voltage arrives at MOSFET 2 through the source, it is forced, or it is switched to the drain of that MOSFET, that's 19, going past the MOSFET 2. And at the gate of this MOSFET will be having 25 voltage. This one is the voltage which shall be used for charging the battery. And at the gate of this MOSFET will be having 6 voltage for charging ID. So once 19 goes past here, it will pass through the current sense resistor, and we say this current sense resistor allows the standard amount of current going into the motherboard. It ensures the standard or the correct current goes past there into the motherboard, right? So in case you have an excess power supply, so this power resistor here limits that power going past there, right? Yes. So at here, so this meaning this is the main power line. All the way from the charging port, you proceed all the way past here. So if you test the voltage here, you'll be having 19 voltage. Then you have a circuit which step down that power. So this is the first step for the step down power. So this one, step down power from 19 to 3.3, and this circuit step down power from 19 to 5.0. Same case here, you have main power which is still 19. You know this power is going along these rails, then it branched to the CPU when it is 19. Then here we'll be having a circuit which steps down that voltage to the correct amount of voltage required in the CPU. Same case applied to any other circuits. So here we have 19, U of 19, U of 19. Then this is stepped down into the respective power required, right? Yes. So guys, that's the main power. So when you say the main power, you're talking of the power voltage all the way from the DC in, this is the charging port, all the way past the power inductor, MOSFET 1, MOSFET 2, current sense resistor, and the main supply of these units, of these other units before it is stepped down. You're talking of the main power line. Even this power from the battery, still the main power line, right? Yes, I believe by now you have understood what are the main power lines. It is good when you understand those power lines. It is easy for you to do the diagnosis. You'll be able to identify which component is not functioning well, or which component is shorted, or whichever component which is faulty. It will be easy for you to identify those components, because you expect whatever voltage here to go past that MOSFET, to go past this other MOSFET, and all the way through into the motherboard, right? Yes. Still guys, we call this one these are still the main power line, this 3.3 and 5.0. So whenever you are missing one of these voltages, 19 voltage or 3.3 or 5, when you miss either of the three, still you have an issue of no power in your motherboard, right? So it's a must for you to have the main power, that's 19, and also you need to have the 3.3 voltage and 5.0 voltage, and of course main power which is 19.0 voltage or less, right? Or maybe 18, 20, whichever voltage. So this is the main power supply. We call it the main power supply. And without any of this, you will be talking about no power in your motherboard, right? Yes, and we said that 3.3 voltage goes into the CPU. Then you have 5.0 voltage, that one goes into the PCH, and PCH and the CPU are one and the same thing, right? Yes, those are the main power supply. So here with me, I have a motherboard here. We can use this one as an example. So this one, the circuits I was talking about. So you have the main power supply from here, from the port. This is the power port. You have the inductor. This is the inductor. This is the main power supply. So I hope you know how to test for the positive terminals for the port. Those positive terminals, if you test, you will find the continuity between the positive terminals and the power inductors. So these are the inductors. I don't know whether you can see them. Yes. So this is the inductors. This is MOSFET 1. As I said here, we have inductor, you have MOSFET 1, and then you have MOSFET 2. So this is MOSFET 1, this is MOSFET 2, right? And this is the charging IC I was talking about. So this one controls the power from here to here. Then here you have the current sense resistor, right? Yes, of course, here we have the circuit coming from the battery. So this is this circuit which joins the main power line from here, right? So this is the circuit. So once they join together, they go now into the motherboard. Then the first branch we say we have 3.3 line, 5.0 line. So that circuit for 3.3 is this one. So we have the circuit here. This is the circuit for 5.0, and this is the circuit for 3.3. You can see they are like family, because you have an inductor and an inductor, same inductor. If you see the coding at the top of this inductor are the same. They both have the two MOSFETs. These are the MOSFETs for this circuit, 1, 2, the small ones, and still you have 1, 2 other MOSFETs here. I don't know whether they have capacitors at the back. I'm not seeing any. So, but they also should have the capacitors. So you can find the capacitors in both the power lines, these two circuits. Then they have this special IC, this one. So this IC, so here at this circuit for 3.3 and 5.0, you have a special IC there which is responsible for stepping down that power from 19 to the respective 3.3 and 5.0. And this IC, the small IC, this one, we normally call it the mother IC. This is mother IC. Why do we call it mother? Because it is the mother of the two. So this is a family. We treat this circuit as a family. So you have 5.0 and 3.3. All of the two voltages must be there, right? They must be there. Without those voltages, I don't think even with breakers that motherboard would power on, right? Yes. So this is the IC I was talking about. We call it the mother IC. Then apart from that, we also have the circuit which supplies them. So this is the CPU. Inside here we have the CPU. Then here you have the circuit which is responsible for the RAM. This is for RAM power supply. So this is DDR3. So I expect at this inductor, the output of this circuit will be having the 1.5 voltage, because this is DDR3. Yes, and again here you can see we have very small inductors here. So these are the power supply for the processor. So maybe this one, it will be for this power supply. I said we have 1.05. Here still we have another power supply for 1.5 voltage, and of course probably there is another one somewhere, maybe at the back. At the back I am not seeing any. However, I can see there is another one here. So this maybe it's for the 0.8 vehicle or whichever. So in fact, what I'm trying to say, you must have the 3 voltages. So in short, for the CPU, I'll be having 3 different kind of the power circuits, right? So I hate to have 1.05 here, 0.8 here, and 1.5 here, whichever way, right? Yes. So same case with the PCH or the NOR bridge. So for this laptop, I believe it is integrated inside the CPU. So on other laptops, you find you have the GPU. This is the empty slot for the GPU. This is the slot for the VRAM. And I believe the BCH is integrated inside this CPU, right? Yes. And of course, you have the power supply for the RAM, which I have already discussed here. Yes. So guys, thank you so much for being patient with me, and I appreciate your patience. And please like and subscribe to this channel, and may God bless you, and see you in the next video. Bye bye.